Hey everyone, let's give this thing a shot. I got that green light, baby. I gotta be moving out of here. I got me that green light, baby. I gotta be moving out of here. I'm gonna see all of my friends now. Seems like it's been 2 years. We're calling the breeze as we move on down the road. We're calling the breeze as we move on down the road. We still wear our masks and keep our distance. Gotta live right by that code. Wear a mask and keep our distance. Still living by that code. That's it. All right, everyone. Mr. Pat hacking back at you. Let me turn off my amp here. Okay. Hello, Boys and Girls Club. Welcome back. Gonna run a lesson on equations. That was an old sloppy rock shuffle blues thing. Fun to play with a band. Get a lot of parts to it. By a gentleman named J.J. Cale. That swamp feel to it. A lot easier said than done. He's just got a knack that other people don't. J.J. Cale. I want to look that up. And pretty cool music. Okay. I'm going to spin this as I am apt to do, and we're going to have a lesson. We're going to kind of give a little bit of a review branch away day. So solving equations is something everybody does at every level, and it never hurts to have kind of a summary review of that type of thing, and that's what today's focus is. So I got 4 total problems. We're going to do them all with you, give you a taste. I taught algebra for a really long time in pre-algebra, so I know the things students stumble on and what to remind you of. And at the end, we'll do one like yesterday with the squares also. So here's our first problem. So one thing about solving equations, a solution, you hear things like isolate the variable, find the value of the variable. So you always try to get the variable in the equation by itself. To get an actual numerical solution, there'll be only one variable. Unless if there's 2 variables, there has to be 2 equations. You've done that with systems and whatnot in 8th grade. Substitution, elimination. But for this, it'll be a single equation, single variable, and our job is to find the value that makes this equation true. That's called the solution, solving it. So we want to get that in by itself. So you don't think left and right, you think, where's my variable over here? So I got to get rid of this, but before I get rid of anything multiply or dividing, I get rid of the subtraction addition. So this is add 15, so I'm going to subtract 15. Or you can think plus negative. So if you prefer thinking like that, that means the same thing. So 15 plus negative 15 is 0. That's a good thing. Bring this down. Don't lose your negative sign. That's one thing a lot of students carelessly stumble on. Okay, you always have to know positive and negatives. These are both negative, so you plus them together. You get 42, but adding two negatives, it's still negative. So we're after getting our variable by itself. We do that by getting rid of what's being added or subtracted first. Okay, now we're over here. This is multiplication. So the inverse operation is division. Notice it's negative 6 times in. So to make that go away, I divide by negative 6. Okay, you won't have color coding. You'll all be in gray or blue, whatever you're doing your work in. Negative 6 divided by itself is 1. That's what I want. So I got my 1 in. I'm like, yeah. 42 divided by 6 is 7. Really common for people to put that. That is incorrect. This means negative 42 divided by negative 6. So that's a negative divided by a negative. So the answer to this equation, the solution, is n equals 7. You can always check by plugging that back in here and seeing if it works, and it will. So that's a straight up two-step equation. I picked it because I put the variable on the right side. That makes some students stumble, and there's all those negatives to deal with. So always worth practicing that kind of thing. As you move higher up the math ladder, you do this as routine parts of many more complicated problems. So you want to be really good at this stuff in terms of not making mistakes. Okay? Bam! Bara äta någon mån, you can do number 2. Okay, so we're on example number 2. Okay, here is 14 plus n over 7 equals negative 70. Now this one, I never really did wrap my brain around why people get confused by it. The 6n, negative 6n, 3n, all those people get. This throws them off. So, but the same thing holds true. You want the variable by itself. So you're going to have to do something with it, 7. But first, you got something being added over here. You got to attack that first. You got to get rid of that first. So we are going to minus 14 on both sides. 14 minus 14, 0. So I got n over 7. Those are both negative, just like the last one we just did. So negative 84. Now people get so divide happy, they end up doing the same thing on every equation. This is not that type of equation. You always do the inverse. So this means n divided by 7 here, so you multiply by 7. You can go like this. What I show in my classroom so they understand is you're actually multiplying by 7 over 1 because these buggers will cancel. If I multiply by 7 on the left, I multiply by 7 on the right. I don't need to write the fraction there because this ain't a fraction. So these canceled. That solved what I wanted to happen. I don't know what that is, but I'm going to find out. Okay, I could do it in my head. I know 7 times 4 is 28. 7 times 8 is 56, but that's actually 80. So that's 560 plus 28 is 588. Let's check our work. 28, carry 2, 56 plus 2, there you go. Okay, what I tell all my students all the time, check. So you're looking over here. You got a negative times a positive, so it's negative. Make sure you put that negative if it belongs there. Students get careless. They see the equal signs as negatives, things like that. That's the answer for that. Okay. So when you're looking at these problems, you're doing what's called an inverse. So if you had like 5x equals 30, this is multiplication, so you divide. But if you have x over 5 equals 30, this is division, so you multiply. That's how your brain thinks of it. Okay? It's kind of a quick snapshot today. Give you guys a break from all that quadratic stuff. When we pick that up again with all our square roots, it's going to be a trip. So kind of taking a mental siesta here a little bit, but this is good practice here too. Okay, ready? 3x minus 8 plus 10 equals 55. Okay. So it's an interesting problem. So you have two ways to do it. One is you can use your distributive property. That's no problem whatsoever. So if I do the distributive property here, I will get 3x minus 24 plus 10 equals 55. Then I'll combine that. I'll get 3x plus negative 14 equals 55. Get rid of that 14. 3x equals 69. Divide by 3. 2, 3, what is that? 23. So that's legit. Okay. You can do it a different way. Let's say instead you go like this. We still get rid of what's being added or subtracted. Can't do this. Consider this locked together with multiplication. Can't get rid of the 8 because it's inside the brackets. That cancels. 55, take 10 away is 45. Now we're not going to do distributive property. What we're going to do instead is, this I already told you is multiplication, so we're going to divide by 3 on both sides. Alright? Those 3's cancel to 1, so I get x minus 8. 45 divided by 3 is 15. Then it's a pretty simple one-step equation. This is subtract 8, so I'll add 8. And lo and behold, there you go. So it doesn't matter which way you choose. A lot of students might prefer to do this. A lot of students might prefer to do that. We kind of show both ways. So I'm getting sloppy over there. Writing across this whiteboard can be cumbersome sometimes. As a teacher, I try to show the various ways, and then you get to choose the way that works best in your brain. And that's the one you should be doing. Some you have to do it a certain way. But the more ways you learn, the more you're in charge of what works for you. Okay? One more equation. We're going to play into yesterday's deck. Square roots. You'll recognize the difference, hopefully, when you see it. It's a very important difference. Okay, fairly complicated one. 4 bracket n minus 9 bracket squared. That's important. Minus 5 equals 315. Okay, so this one's a trick. This one takes more work, more concentration, but you attack it the same way you did the last one. Okay, and we're going to do it the second method, not the distributive property, but you could do it that way. So we're going to get rid of the 5. So this is subtract 5, so I add 5 to both sides. Cancels. Bring this down, we call it. Okay, right here, take a breath, step back, make sure you write the squared. 315 plus 5 is 320. Okay. Now this is another instance where the outside add subtracts gotten, it's gone. So now I divide. See, I can't do that division until after I get rid of this. Whatever you do on the left, do on the right the same thing. The 4's cancel. I get n minus 9 squared equals 80. So far, so good. Okay, you got all that? So what I'm going to do is pick this back up in the top. I'm going to erase all this. I'm going to rewrite this. N minus 9 squared equals 80. So if you... more of these on the lesson from yesterday that shows. Now, I want to make this disappear. The inverse of squaring something is square rooting it. So if I take the square root of this side, the square root of x squared is x. The square root of 8 squared is 8. The square root of n minus 9 squared is n minus 9. If you haven't had that developed for you, then just going to have to take my word for it right now. This isn't a full-on long class period. It's just a taste, and you had that already in your algebra class. Okay, the rule, though, is one thing never changes with equations. Whatever you do to the left, you got to do the same thing to the right. So if I square root the left, I got to square root the right. So the square root of 81 is 9. The square root of 64 is 8. So 80 is just under 81. So it's not 9.1. It has to be 81 to get to 9. So it's right before 9. So a little less than 9, because 80 is a little less than 81. So approximately equal to 8.9, I'll call it. A number almost up to 9, but not quite there. Okay. All right, now this is what we learned yesterday. There's more to it than that. Every time you take a square root, there's two answers. There's a positive and a negative version. So this has two separate solutions. So we separate this into two equations. N minus 9 equals the positive version. N minus 9 equals the negative version. That's where this gets tricky. That's what algebra is like. Okay, so this one you add. And don't forget, 9 is like a whole number, 9.0. That cancels. So one of your answers is 17.9. Add 9 here. You got to be really careful. If you don't do it like that, what you're going to do is think the answer is 1 or 0.1. It's not. So this is a positive here, a negative there, so you're subtracting. But you got to put that bigger number. What did I say? Not. I meant to say 8. It is 0.1. What people will do is if they go like this, they'll just subtract the 9s and think it's negative 8. That is not how you do it. Sorry, my mouth did not say what I wanted it to. So when you set this up, always put the bigger one up on top. Okay, now I got to borrow that down and put it over there. So I get 0.1. And the bigger number is positive, so n equals 0.1. Those are my two answers. I guarantee you that's right. You're going to find out when we revisit the quadratic functions, these are actually the x-intercepts, those zeros we talked about, but we'll show you that in another day. Okay, all right, that's enough for today. Those are highlight, very important review of solving equations. Got a taste of some old funky rock and roll, J.J. Cale again. And I just want to say thanks. Okay, wish everybody was listening to these. Maybe T's giving them to in the Instagram, whatever. We'll see what happens in the summer. So Mr. Pat, our little Wonder Boys and Girls Club, as always, are reaching out to you. We care about you. Take care of yourselves. This newfound freedom, that's what I rewrote the words for Call Me the Breeze. You still got to follow smart rules to keep yourself and others healthy through all this, so we don't let this thing come back and bite us any harder. Okay? All right, aloha for now. We'll see you next time. Wonder Boys and Girls Club, Mr. Pat signing out. Aloha.